Okay? So, last day we talked about prime factorization, the factor tree, greatest common factor, and lowest common multiple. We used prime factorization for a couple things. One of them was for lowest common multiple. We broke down all numbers into their prime factors.
Excuse the interruption. All grade 10 and 11 students who are interested in the dual credit presentation in the library, you can please go there now. Thank you.
Okay?
Yes, I know.
Okay, so what I want to see, well, when we use prime factorization, twofold. When we are looking for greatest common or lowest common multiple, and as well as if we're going to check to see if numbers are perfect squares or perfect cubes. How we do that is you choose a number. First off, any number can be made up of all prime factors. That's okay. How do I know if what the prime numbers of any number is? How could I figure that out? If I wanted to find out the number 96, and I wanted to break it down into all its prime factors, what would I do? Factor tree, go. Get you in there. Hate it when people. Is that one dry? Good. So remember, after we finish the factor tree, I also want you to tell me what, I guess in the horizontal line of what all the prime factors are. Okay? Question, is there only one way to build this tree? No. Okay, what's the starting point that some people used? What's one starting point?
8 by 12.
Jansen, what did you use? 32 and 3. Is there another one? 48 and 2. Is there another one?
8 by 12.
16 and 6. 8 and 12. Okay? All of those numbers, all of those trees, will work into building your factor tree. I circle 3 because it's my prime factor. 32 is not prime. How can 32 be broken down? What is it? Divide by 2. 2 and 16. 16 can be broken into 8 and 2. 8 can be broken into 4 and 2. 4 breaks down into 2 and 2. How do I rewrite this factor tree? How many 2's are there? 2 to the power of 5 multiplied by 1, 3. So if I take 2 times 2 times 2 times 2 times 2 times 3, I get 96. We can actually use this method when we are building or determining whether or not a number is a perfect square, a perfect cube, or neither. One way to do that is by taking our prime factorization for our factor trees and grouping them. Now, if I'm using perfect squares, how much am I what am I making groups of? If I'm making perfect squares. Anybody know? Groups of 2. Perfect. Now, with a perfect square, I want to make even groups so that no prime number is left out. So I'm going to use 96 as an example, and I also want you to use 64 as an example. Find me the factor tree for 64, and then see if you can find a comparison. And I'm actually going to move this a little bit. 64 can break down into what?
8 and 8.
8 and 8. 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. If I were to rewrite 64, how many 2's do I have that make up 64? 6. So here's my question. First off, Tia or Tyra, if one of you want to miss these classes and borrow for spray, that keeps the desk a little bit cleaner so you're not sweating.
Okay, it's probably when I'm done.
Oh, is it still here? Perfect. Right
When
there.
I'm done, I'll probably do that.
Yeah, for sure.
Until
Don't.
then, probably not.
It worked out well just so we're not smudging it. I'd hate to have Mr. Palmer come in and see the Okay. What is the big difference between 2 to the power 6 and 2 to the power 5 times 3? How many? Let me ask you this. Can I make even pair groups of 2 with 2 to the power 6? How many groups of 2 can I make? I can make 3. I could take one pair here, one pair here, and one pair here. When I make groups of 2, for every group of 2, I take the one number, or the number that I use, and I write it once. 2 times 2 times 2, which gives me what? 2 times 2 times 2 is what? 8. Which is ironic because the perfect square of 64, the square root of 64 is 8. Can I do the same for 96? How many groups of 2 do I have? I've got one here, and I've got one here. I have a 2 and a 3 left over. Do you see the difference? All of my prime numbers are grouped here. However, I can't group 2 and 3 together because they're not the same number. Having said that, what does that tell me about the difference between 96 and 64?
96 isn't a perfect square.
96 isn't a perfect square. Okay? Now, the calculator will tell me that easily. I just put in square root of 96, and if I get a decimal number, then I know it's not a perfect square. This is the proof. This is where it's coming from. That if you take your prime numbers, you can group them into sections where if you have all of your prime numbers grouped and there's nothing left over, it has to be a perfect square or a perfect cube. What would your groups be if you were looking for the perfect cube? Here we were looking for groups of 2, now I would be looking for groups of 3. Using 64, 64 is a very unique example because how many groups of 3 can I make here? Here's 1, here's 2. What is 2 times 2? Equals to 4. What is the cube root of 64? 4. 64 is a very unique number because not only is it a perfect square, it's also a perfect cube. Okay? So you can have 4 different types of numbers. You can have a number that's just a perfect square, a number that is just a perfect cube, you can have a number that's both a perfect square and a perfect cube, or you can have neither. Where does 96 fit? Could it be a perfect cube? Could it be a perfect square? It is neither. So having said that, I want you to take these 4 examples, and I'm actually going to scrap this one to be 36, and this one to be 224. And I want you to prove, using the factor trees, whether each of those 4 numbers are perfect squares, perfect cubes, neither, or both. Okay? I'm gonna get you a bigger dot, and then I'll get you to spray. Like I said, I'd hate to have the smudges stay, and it gets on your hand. Okay, I want to see everybody try all of these to make sure they know, or if they can tell me, dying to know, whether 144, 224, 27, 36 are they perfect squares, perfect cubes, neither, both. I guess that's it. 2 times 2 times 3. What's 2 times 2 times 3?
So 27 equals
Cool.
100.
And you know that because, do you have any
3 times 3 equals
prime numbers left over? No.
That's
So you know it has to be a perfect square.
cube, right?
Now, could it be a perfect
3
cube?
times 3 times 3. No, there's 2 groups. Is that not what he said?
No.
I don't know.
Good.
So the opposite of it. Is this right? You group them like that? Or is it supposed to be 2 groups of 3?
What are you coming up with? Being number 27, are you saying it's a
Perfect cube.
neither, perfect cube, perfect
Cube.
perfect cube? Because you can make how many groups of 3?
So, but
No, you can only have one group of 3, right? Because you have this right here. You can't make a group of 2. You make one group of 2 and you have one left over, right? So it can't be a perfect square. Does that make sense? But I have a group of 3. That means that 3 times 3 times 3 gives me 27, which makes it a perfect cube. Yep. So can you make one group of 3? So that tells you that
wait, what is that?
if I took the cube root.
Wait, is it 4? Does that have to be like 4?
That makes sense.
4 dimensional.
Wait, you're supposed to do factor trees for all those?
Yep. Factor trees for all of those, and tell me whether or not each number is a perfect square, a perfect cube, neither, or both.
Wait, that's the same as 3 to the power 3. No, I'm so confused. What was 4 dimensional? I'm so confused. What
How
was
many
4
groups?
dimensional?
How many
Doesn't
twos?
Disneyland know what in Disneyland, I went to, they had like little shows, like 4 dimensional.
One group of 2.
And it was like you would like spirit of all that you would see it. So it was like a bug screen. You can see like depth perception, you can feel it. Well, you can hear it anyway. So, is this, let's see any movie, Chad? Yeah, oh. Oh, so the 4th dimension is depth perception. No, it's feeling. Oh, sure. 3D is depth perception. Yeah.
Well, ironic, because the square root of 144 is what?
I love feeling movies.
I know.
Anytime you guys
Oh,
go
56.
and then all your prime numbers are accounted for, you have a perfect square.
6 will be,
Try another number.
25, 28, 2, 27,
9. Oh, 9 times
7 is a prime number. 7 times 9.
So this actually becomes 3.
7 times 4 is 28. So,
Try to make it so that when you branch
it's
off
not
the score,
two-dimensional.
where that branches from.
So it could be a perfect cube or a perfect square, I mean. Is it perfect into groups of 2?
The 2 to the power of 537 is, so is it a perfect square, perfect cube, or neither? Neither,
No
good.
wonder. Isn't that 225?
What would be the perfect square?
What's 1 star for a perfect square?
Yep, we're gonna go 36. Okay, 144, just to get us started. When you do your factor tree, what does it break down to? 2 to the power of
4.
4 times 2 to the power of, or sorry, 3 to the power of 2. How many groups of 2 can I make from 2 to the power of 4? How many groups of 2?
2,
2 squared. How many groups of 2 can I make from 3 squared?
1,
Just 1. What's 2 squared times 3?
12,
12. Are all of my prime numbers accounted for? And is 144, the square root of 144, 12?
yeah,
So what do I know about 144? It's a perfect square. What about 224? What is the prime numbers for 224? Anybody get that far?
2. Okay, go what?
2 to the power of
5 and 7.
7. Can I group all of my prime numbers and leave none out? No. What's the issue? What number's the tricky one? The 7. Because the 7's here, so this was a perfect square. What's this one going to be? Perfect square? Perfect cube?
None.
Neither? Okay. So this was a perfect square. What about 27? 27, when you break it down into its prime numbers, or prime factors, is equal to 3 to the power of 3. How many groups of 3 can I make from 3 groups of 3? Or 1 group, sorry. Wow, 3 threes. I can make 1 group, which is the number 3. Is that a perfect square, a perfect cube, neither or both?
no. So
It is a perfect cube. What about 36? 36 breaks down into
6 times 6.
6 times 6. What are all the prime factors?
Oh,
2 to the power of
2,
and 3 to the power of.
2,
Can I make groups of 2?
yeah,
How many groups of 2?
1, 3,
1 that makes 2, and another one that makes 3. 2 times 3 is equal to 6. All my prime factors are accounted for. And I made groups of 2, which gives me a perfect square. Does that make sense? Okay. Whether you're dealing with perfect squares or perfect cubes, if you can make even amounts of one term or one prime number, that will determine, and have no prime numbers left over, that will determine whether or not you're dealing with perfect squares, perfect cubes, neither or both. Okay? So that concept's good? Because now we're going to move into the area model. And we're going to actually start multiplying 2-digit numbers, 1-digit numbers, and actually we're going to get into a point where I can show you how to multiply something like this and not be completely terrified. Okay? Before I do that, I want you to break down and tell me the groups or the base of numbers that we have in our society. We break down numbers into certain into groups of 10s. Why do we use base 10? Anybody know why? It's simple. Why is it simple for us? Yeah? And why do we know why we use the increments of 10? How many fingers do we have? 10. Total. Okay? We have 10. There's a reason why we use base 10, because we have 10 fingers. Actually, there are places there's actually places in the world that use base 20. Why do they use base 20? 10 fingers, 10 toes. If we were aliens and we had 12 fingers, what do you think their base would be? Base 12. Okay? That's where that concept comes from. If I'm using base 10, what is the smallest number that I start with? Smaller than 10.
0.
1. I have numbers that start at base 1. Or I have groups of 1s. What's the highest number of 1s that I can have? How many groups of 1 can I have before I go on to the next level? 9. What's my next level? 10. I can have groups of 10. How many groups of 10 can I have before I go to the next level? 9. What do I have? What happens after that?
9 more.
I could have 99, then I become groups of 100, and then I had groups of 1,000. Okay. We use this piece to help us determine and break down numbers into their bases. So if I gave you a number 1738, where would everything break down? How many groups of 1,000 do I have in 1738?
1,
I have 1. How many groups of 100 do I have?
7,
How many groups of 10 do I have?
3,
How many groups of 1s do I have?
8.
8. So I have 1 1,000, 7 100s, 10 3s, 3 10s, and 8 1s. Okay? Keep that in mind how we break this down into to represent our number. Okay? Does everybody know how to multiply or find the area of a square?
Yes.
Does everyone know how to find the multiplicate or the area of a rectangle?
Yes.
Fantastic, you're going to do well in this course, or in this section. If I give you an area model or an area that has the dimensions of 4 by 4, could you tell me what the area is?
16.
It's 16. Okay? How I know that is I use the base times the height, 4 times 4, which gives me 16. The same can be said for 6 times 6, which gives me 36. Okay? I can use that same concept for any rectangle. 4 by 6 gives me 24. You're good with that so far, right? The idea that we're taking those two numbers, the two dimensions, and creating the area of that rectangle or square. What happens if I give you a number that looks like this, 4 and 13? Yes, I could do that with my calculator, and I completely encourage you to do that, but if I want you to understand this concept, I want you to kind of disregard the calculator for a second. When I look at 4, what base do I see here? What group am I dealing with? 1s, 10s, 100s, 1000s?
10s.
Ooh, I'm dealing with 1s here, just with the 4. How many groups of 1s do I have?
4.
And 4. So I'm only dealing with one row here. But when I look at 13, what two groups do I see?
1.
I see 1s and I see
10s.
10s.
You said 10.
Chad, how many 10s do I have here in 13? I have one group of 10. And how many groups of 1s do I have? I have 3. To make sure that when I split them up that it works out evenly, I just simply have to add 10 plus 3. Gives me 13, that's what I'm dealing with. Now, I can look at this question like two rectangles. My first rectangle has a dimension of 4 by 10. What's the area of that rectangle? 4 times 10. 40. My next dimension is 4 by 3, which gives me 12. What is 40 plus 12? 52. You have just figured out how to multiply 4 by 13. Good? Try one more. Give me a 1-digit number. 8. And a 2-digit number. 25. Go. 25 on your desks. 8 times 25. Actually, that's an easy one. Do 26.
56.
8 times 26. Using the area model.
64.
Using the area model. You can use the calculator, but I want you to prove the area model. Fantastic.
What? 64.
Agree with this.
Oh.
6 is good, this has to be 20.
Oh.
So that
I
should
see.
be 0.
I said something. 1.
What's 8 times 2? 16. Add 0.
208. 6. 6 times 8. 48. Aha.
Actually, I think that's how to look at your nose. This is 6. Is it 20? 20?
Yeah, exactly. No, you're right.
156, that's 7 times 8.
Add these together.
Who can tell me what they actually? I saw a lot of people split up this number. Oh, wow. Okay, that was good. How did I split up? Did I have to split up 8 at all?
No.
No, I'm not dealing with 8 10s. I'm just dealing with ones. So I can have one group of 8. I have 8 groups of ones.
Done.
Can I split up 26? What do I split up 26 into? 20 and 6. Okay, I have 2 groups of 10, which makes 20, and 6 groups of 1s, which makes 6. 20 plus 6 equals 6. This makes multiplication a lot easier. What's 8 times 2?
16.
16. What is, and I have an extra 0, so that makes 160. What's 6 times 8?
48.
Can I add those two together? 160 plus 48 gives me 208. You have just figured out what 26 times 8 is. Mind blown. Give me a 3-digit number. 127. Give me a 2-digit number. Give me a higher number than 24. 67. Go. 67. Go.
John's. Oh, that's a small box. Yeah.
Yep.
Did I get to this?
You're doing your head right now.
No, but infinite.
You do.
So it's 127.
Don't be silly. Condescending all the time.
7 times 20. Wait, this is
140.
this is a big number.
140.
This is a big number.
Yeah.
7 times 20 is 140.
Yes, Dad.
7 times 7 is. I don't care.
Write that down.
Is it 42? What can we do this? And all the others.
No, that's good.
140.
No check.
You can't think of it.
60 times 100.
60 times 100 is 6,000.
Yes.
I don't
Okay.
get it.
Quick question for you. I'm not going to answer for you just yet, but actually looking at my terms here, my numbers, can I figure out how many rectangles I'm going to have in this box? 6. I have 2 terms here, 10s and 1s. How many terms do I have here? I have 3. I have 100s, I have 10s, and I have 1s. 3 by 2 gives me 6. What are the numbers that I'm splitting 127 into? What 3 terms? 100, 20, and 7. I have 1 100s, I have 2 10s, and I have 7 1s. What about 67? Jansen? How am I splitting 67? 60 and 7. Awesome. Okay? Now you can solve it. It's going to be a big number. Why? So here's my other thing for you.
I got it.
Okay, but yeah, it was still work. But do you see why you would split? Yeah, it's just a little bit harder. Okay.
But is it?
8,700?
Oh. 8,719. Whoa, 8,489.
I did something. Okay. I did something.
Oh,
That's 60 and 7. That's 420, right?
yeah, I got it.
I forgot to add the 0.
You, that's good. I need to start putting in like 7 beers and stuff, eh?
And it's really just better to add it twice, because then all of the other stuff was confused, so it's
Actually, that's awesome. It's a really good one.
Why would
I like that breakdown.
because for me to set a form, you're
I'm
gonna do conditions, I can't.
Since I've seen this, I've become so much more visual with regards to how I solve it.
8409? No.
85.
Like,
I got 8489.
just put at whatever time.
I'll put like the highlights, like this is Garrett.
Oh, that's hard to.
Then you're not just like, oh, I have to sit here for an entire. I'm hoping it's not going to take a whole hour. But yeah, like if it's an hour long, it's like, okay, now we're talking about this. Now we're talking about this. Now.
I ate 500.
Okay.
You forgot to add one.
Very quickly, this now, do you see how this multiplication, this breakdown actually makes multiplication a lot more easier in your brain and not having to rely on a calculator? Here's the strategy I like to use. 6 and 1 is what? How many zeros do I see in 16 hundreds? 1, 2, 3. 6 times 2 is? 12. How many zeros are 16 and 20? 2. 6 and 7 is 42 with an extra 0. 7 and 1 is 7 with 2 zeros. 7 and 2 is 14 with a 0. 7 and 7 is 49. Okay? Do I have all of my squares completed? What do I do next? I add them up. I can add up this side and this side, and then I can add up the total here. And I multiply.
Add the one right there.
6,000, that makes 7,200, that makes 7,620. This makes 700, 840, 889. If I add those two numbers together, I get 8509. Did anybody not get 8509? Does anybody not see how they could get 8509? You don't see it? Okay.
Oh, there you go.
It's not there. You guys erased it. All right. Very good.
Probably reset.
I want you to try these next two on your own. So 30 times 16 and 138 by 23.
Wait, actually, I need to.
Yeah.
We only go
30 times 16.
That's done. Like Chad, no. No.
Oh, okay.
18.
Okay, there's one more loser.
How many groups of 10 do you have? 3. Okay, so what's that represent? 30. And how many zeros and how many ones do you have? How many ones do you
Okay,
have?
I'm not gonna mess up this one.
How many ones do you have? You could do it that way. You could just have 30
I
here,
did
or you could have
20 times 0.
30 here, and it'd be 0. So I have 3. So I have 3 sets of 10, which makes 30, and 0 ones, which makes 0. Looking at 30 and 16, how many rectangles should be in this box?
6. Oh wait, top one. 4.
Yeah, there could be 2. There also could be 6.
4.
No, there could be 4.
Huh.
Oh. No. Okay, Tyra, why'd you say there could only be 2?
There are no ones in the 30.
Interesting. How can I split up 30? 30 could be looked at as 3 groups of 10. And how many groups of 0? Sorry, I just gave you the answer. How many groups of 1? There's 0. Any number multiplied by 0 is equal to what?
0.
Okay? I can literally just cancel that out without even having to break down 16. How do I break down 16? Just for giggles. 10 and 6. Jansen, good comment actually. You could use 8 and 8. Why could I use 8 and 8? 8 plus 8 is equal to 16. If we go back to our base 10, does that make sense?
No.
Not with our base 10. It mathematically could make sense, you're just doubling it. However, if we're following that procedure of tens and ones, or hundreds, tens and ones, let's keep it this way. Now I can simply do the math. Listen up. 3 times 1 is? How many zeros? Extra 2s. 6 times 3 is 18
8 times 8 is
with an extra 0. What's 300 times plus 180? 480. Remember that number, okay? Please and thanks. Okay, last one, and then we're going to go on to your first curveball. 138 times 23.
Yeah, Daniel. I need it too. Taylor tossed it twice. Thank you. Are you erasing? We should erase everything.
Keep on writing the wrong number in the spots.
What part where?
I wrote 8 here. And on the last one I forgot to carry over the 20.
Oh.
Yeah, check this.
Except you get 2,000 here. No, 2,000. I would check your process is right, but the adding is.
It was Todd bad. Yeah, it's like so many Todd.
What do you do for
Squad in the class. So, really? Oh my goodness. Michael's actually super smart. He's like giant memory almost.
Alright, without having to do any math right now, how many box or rectangles are going to be in my box? There are going to be 6. How do I know? I'm dealing with a 2-digit term and a 3-digit term. Guys, girls, listen up. 2 by 3 makes 6. How do I split up the 2-digit term? How does 23 get split up? 20 and 3. How does 138 get split up? 130 and 8. Now I'm multiplying. 20 times 100 is? 20 times 30 is? 20 times 8 is?
160. Wait.
3 times 100? 3 times 30? 3 times 8? When I add all this together, I get? Awesome. Awesome, awesome, awesome. Alright. So now, I think we've got that concept down pat, eh? So let's throw a curveball at you. Before we do that, I need to do a little bit of a refresher on algebra and how we add, subtract, multiply, divide variables. So I need everybody's attention up here for 30 seconds. A little longer than 30 seconds, but I need your attention up here. First off, how many terms is 5x? First number that comes to your brain when you see that and I ask you how many terms are in 5x. Why is it 1? It's just one term. The simple strategy I use to determine between 1 and 2 terms and 3 terms and 4 terms, terms can be separated by addition and subtraction. Okay? So because I don't see any addition and subtraction here, I can assume that how many terms this is? 1. If I gave you 5x plus 3, how many terms is there now? There are 2. If I gave you 2x squared plus 5x plus 3, how many do I have now? 3. Fantastic. Do you notice the order which I'm writing these terms? I'm going x squared, x, and 3. Let's go back to that rectangle that we had, that we talked about, our base 10 rectangles. I want to draw a new one. I'm going to use the same 4 groups. And I'm going to use a very gruesome word to grade 9 math from last year. How many people remember algebra tiles? Ugh. We're not going to use them. I just want to reference them for a second. What is the first shape that you remember from algebra tiles? What's one shape that you remember?
Square.
The square, the big one.
The big one. What was the big? And so there was the big square. There was another. There was a stick. And what was the smallest one? The smaller square. What did that small square represent? A 1. Okay, in our bases, when we're dealing with variables, it still is valued as 1. However, instead of writing 10, when we write base 10, what was our next grade or our next level? It was x or the bar. And then what did the square, the big square represent?
Square.
It was x squared. Okay? And if they kept going, the next shape or object you would have saw was x cubed with an actual cube. Okay? So we actually break down all of our variables, one, by term. So these, anytime you're dealing with a group of ones, that's one set of terms. Anytime you're dealing with x's, that's a whole other set of terms. X squared and 3x. Does that make sense? So that's how we separate them. When I'm adding these terms, I cannot add terms that are in different orders. So for example, if I have 3x squared plus 2x, can I add this to 5x cubed?
No.
No. This actually stays as 3x squared plus 2x. Because in addition, guys, I need you to listen here. Good? Okay. Because x squared and x are not identical, I cannot add them together. However, if I have 3x squared plus 2x squared, can I add those together?
Yes.
Yes. What does it equal? 5x squared. Okay. Now with multiplication, if I give you something like this, 3x times 2x, I add the coefficients of the numbers just the same, or not add, multiply them. What's 3 times 2? 6. And I have a variable which is x. And what I do when I'm multiplying variables that are the same, I actually just have to count up how many variables are included in this multiplication piece. So in this one, I have how many x's here? 2. Here's where I write my exponent. Okay? If I have 3x squared times 2x to the 4th, I still have my 6. I'm dealing with my x, but how many x's are being multiplied here now?
6.
I have 6. That's the exponent goes up here. Okay? We're going to talk more about exponent laws in the next unit, but this is kind of the basis of what I want you to understand right now for the next piece, okay? That make sense? Does anybody not get that so far? Okay. So the big thing I want you to remember is, yes, these pieces here, you cannot combine numbers unless they're or variables unless they're identical. When you're multiplying two variables, you just basically are counting, and that's where the exponent comes into play. And terms are separated basically by ones, x's, x squares, and x cubes. And x fourth, and x to the 5th, and so on. Good?
Good.
So here's your first curveball. I have 3x, and it's being multiplied by x plus 6. And how this would look in an assignment or a task would be 3x multiplied by x plus 6. Nothing changes from what we've done before with the 2-digit numbers. Okay? First off, I look at x plus 6. How many terms are there? 2. What are the terms? I have a group of ones, and I have a group of x's. I have 2 terms. How many x's do I have, Chad?
1.
How many ones do I have?
6.
6. Now with 3x, is that 1, 2, or 3 terms? 1. I only have one group of 3x, or I have one group, it's the x group, and I have 3 groups of that x. Now I can simply multiply. Instead of using numbers, I just have variables. I still am dealing with that same dimension of finding the area of a rectangle. What is 3x times x? 3 what?
X.
3x squared. 3 times 1 makes 3. I have 2 x's. I have to represent that in my square. 3x times 6. What's 3 times 6?
18.
18. And I x times 1, I just have 1x. My final answer here is 3x squared plus 18x. Why can't I merge those?
Because they're not the same.
Because they're not the same. One's x squared, one is x. Here's a mind-bending piece for you. What if I told you that x is equal to 10? What does the answer equal? No coffee for me.
900.
Yeah, I'm teaching. What's that?
180. 180. Yeah.
If I told you that x is equal to 10, what number does this give me?
180.
Actually, sorry, let's go here first. What is 3 times x? Or 3 times 10?
30.
30. What's 10 plus 6?
16.
Did we not just do that exact question?
Wait. 3 times 30 times 30.
Didn't we do 30 times 16?
Yeah.
Yeah. What did the answer come up as?
480.
480. What is x times, what's 10 times 10?
100.
100. What's 100 times 3?
300.
What's 18 times 10? 300 plus 180 is equal to what? It's the exact same concept. The whole idea of variables is just a way to represent any particular number that you are choosing. Okay? There is no...
You don't square it.
Okay. There is no particulars as to what that value is, but you treat it just the same. Yep.
So from last year, we told that we're multiplying unlike terms.
Guys, let's not...
If you're multiplying unlike terms, you move them up. Like if it's x, you go to x squared. If it's just a normal, go to x.
Yeah.
If you're dividing, you go down.
Yeah, well, and we'll talk, I'm going to do, because I'm not doing enough justice going back and showing you multiplying and adding monomials, so just one term. But yeah, if I have x and x, I have two of the same, of one exponent, I like to just count them. I know I've got two of them, so I go x squared. Okay? If I've got x squared and x cubed, I've got 5 x's. Okay? Same thing happens when you're just taking away. If I'm taking 3x cubed divided by x squared, I have 3x. Yep.
Okay.
That makes sense so far? So having said that, I want you to try 13x plus 8 multiplied by 2x plus 3. Go ahead. All we're doing is the area. What I want you to start with is I bet you could tell me, because that was simple. If I go 3
What is it?
16, what I want to do is I want to break 30 into 16 into its 10 times 8. I have how many groups of 10? 13. Great.
Wait,
Right? There's 16.
No.
oh,
No.
no.
This makes multiplying a lot easier because you're try that.
Yeah, it's 13x. What
Uh,
is 13?
Same thing, remember 4 by 6? Yeah, we multiply these two together, these two together, these two together, and then you add them all up. Way to go.
You have to add them together.
If they're the same. If you have two x's, you will have to. Like your 39 and 16, you absolutely will. Without having to do any math, how many terms am I going to have in my rectangle or my box? A lot, thanks. That?
Out of 4 or 6?
How many? I'm gonna have.
Sorry.
I have 4.
How many people have 4? How many people had 6? Okay.
We don't have 4.
I would have 4 because I have 2 terms here. I have 2x and 3. I have 13x and 8. 2 terms here. 2 terms here. What are my 2 terms in 13x plus 8? What are my groups? I have groups of 1s and groups of 10. We're not dealing with 10s anymore. X's. How many X's do I have
Oh,
in the top one?
13.
I have 13x and I have 8 groups of 1. What about in this group here? I have how many X's here? 2x and I have 3. Can I multiply this all now? What's 2 times 13?
26.
How many x's do I have?
2.
X squared. 2 times 8 is
16.
16. How many x's do I have? 3 times 13 is? Jansen?
Sorry.
How many, what's 3 times 13? 3 times 13. How much? 39. How many x's do I have?
2.
Ooh, I have 1 right now. What's 3 times 8?
24.
24. Alright. Do I have any of these 4 terms that I can combine? Yes, which ones, Taylor? 39 and 16. Here's the visual that I want to look at. When I do this properly, I break it down x's and 1s, x's and 1s. I have 1 group of x squares. I should have 2 groups, or 2 that are in x's, and I should have 1 that has no variable. So my final answer goes 26x squared plus whatever 39 and 16 is, which is 55x plus 24. Make sense? People are getting it? Yes, no? You want another one? Well, Ryan just got here, so Ryan's going to do some learning. That's fine. Let's go with 4x squared plus. Oh no. Plus 7x plus 6 multiplied by x plus 12. Go. Okay. So now, nothing changes with this theory.
So we can add outside of brackets.
Levi can't
Or
join.
if
6, right?
Levi, you can't join.
So
You can't try to
let's
line
say
up.
Pretty sure it's khakis.
I have khakis.
let's flip this up.
I always wear that.
I have groups of 1s.
I'm wearing
How many x squares?
one day. Like 2 days a week. Like my track pants too.
I have 3x here.
I can wear track pants at night.
Just wear them both.
What?
Just wear them
Okay,
both.
so when you're multiplying x,
You know that.
we have 2 x's, so this is 3 times 1, which is
It's a big number.
Not really.
Like, it's only as big as you want it to be.
3 times 6 is 3 times
Okay.
and then I just have 1 x.
Like, can you hook me up with
This side.
for tomorrow?
Yep. So just like I have 3x squared
Same,
here.
like, me too.
No, Chad, you have a
X times 2. 2 times 1 is just
I
2.
won't wear it.
How do you know what a hat is?
2 times 6 is.
You are discreet stuff. People that have more.
And now I combine it. So I have 1 group of x squared.
Oh, mine's getting
X,
yeah.
no, show me your, no, you're adding. I want you to multiply.
Dino's like offended.
Why would I even show you the area model if I was just gonna get you to add that? Show me the area
It's
model.
water. Like, marker.
To get you started, guys, girls, how many squares or rectangles are going to be in this box? 6. Why? Because we feel like it. Just because. Just because. I'm feeling 6. How many terms do I have here? How many terms do I have here? 2. What is 3 times 2? I have 6. Okay.
I see that too.
Just 1 second. Yeah, I'll be right over.
Mine's like super watery.
That's so funny when Matthew's peeling the apples. I swear, she's like talking to me with like girl.
It's like,
It's like, no, don't do anything, I swear. Matthew's eyes were alright.
wait, not just smoke, it's not. Okay.
Chad's the DNA.
Matthew's allergic to the skin of apples.
Yeah.
And so he pushes the apple and then he rubs his eyes like that. So his eyes get like bloodshot and red. He carries your ass to get Yep, you get rid of drugs. He's sitting there with his eyes red.
Hey, when I said that,
Now I want you to do that.
Levi.
Alright. Next level, guys, girls. Let's break down the terms, okay? Listen up. 4x squared plus 7x plus 6. How many groups of x squared do I have?
So easy. So far, watch it get
4x squared. How many groups of x do I have?
decimals.
How many groups of x do I have? 7x. How many groups of 1s do I have?
6.
6. For x plus 12, how many groups of x's?
1.
And how many 1s? 12. Can I multiply all these together now?
Probably.
Show me.
Super fire.
why didn't you answer really quick? I just really
Like, he was trying to take my backpack. He stopped right here. Like, remember that?
That sounded so weird. It's like, wow.
Yeah. He's too dumb.
I already erased it. I had the same answer.
Am I right?
Good.
Plus or minus?
Yep.
It's a dick. Okay, Daniel.
Okay, let's go. So that's 6 again.
You good?
I like last time I went back to like 45, 55.
There. You have a square now.
Actually, let's take this as a square.
Yeah. Alright, so.
4 times 1 is what?
Yeah.
How many x's do I have in this group here? 2 plus 1 is?
Numbers.
7 times 1 is 7. How many x's do I have in this group? 2. 6 times 1 is 6. How many x's? 1. 12 times 4. How many x's do I have? 12 times 7. I know, why is someone other than Tania, how many x's do I have? 12 and 7x.
1.
I have 1. 12 and 6 is? Thank you. Okay, remember our trick here. To help me combine and make sure I'm combining the correct like terms, the pattern looks like this. Here's 1. These two should be the same exponent. These should be the same exponent, and then there's only 1 here. So I have my final answer is 4x cubed. What is 48 plus 7? 55 x squared. What's 84 plus 6?
Negative plus negative plus positive.
90x plus 72. Good? Make sure you're understanding how to add these like terms up. Okay, last question. Levi, what is the question that I just gave you guys? 4x squared
minus 6x.
Guys, listen up.
Minus 6x plus 12 bracket and x squared plus negative 4. Yeah.
Okay, try that one.
Wait, so you add these together and then it makes negative 4x squared.
So x squared times x is.
Wait, did you plus that?
X squared times 6x is 6x. Yep.
Wait, does it make negative 4x squared then?
Negative 6. Yep, it would.
Which one's combined?
That was okay.
Can't combine any.
32.
I'm not going to change this. This is a matter of let's do one more.
It's like 2. Check it.
I have a 2. Yeah. How is 4x plus 2x?
Oh, it is.
Chad.
Yeah, I think it's so it's plus 24. Wait.
Okay, show me, let's go. I want you to try this one now, okay? Need help, so keep in mind.
So funny.
Just because to me it looks bad, but then
Wait.
Right.
I feel like we're wrong in some way, but I don't feel like we actually are.
X squared. Yeah, 48. Negative 6x cubed.
You're obsessed with
4x. 4x is 4. Negative 16 squared. 4x to the 4th. Negative x cubed. 4x.
Last Saturday or this Saturday?
That's good.
Wait, what?
Alright, for this format. Last one, guys, girls.
Because I need those Bibles. If I don't, break them.
How many boxes are going to be in this rectangle?
How much were you buying?
6, how do I know?
Like almost 400.
I have 1,
On sale.
2, 3 terms here, and how many
I got them
terms
for 200.
in the next one?
They're like 600. They're 4
2.
years old.
How do I split up 4x squared, Levi, minus 6x plus 12? Actually, let's pick on Blake. How do I split up 4x squared minus 6x plus 12?
4x squared.
4x squared
Negative 6x.
minus 6x
12.
and 12. What's the curveball that I've given you so far? What have we not seen? The negative. Okay? So Blake identified that we said, you know what? This x is actually grouped into negative 6s. I have negative 6s of this x. So I'm just going to put that negative in there and incorporate it into the whole piece. Same thing happens with x squared minus 4. I have x squared here, but I have negative 4 here. So now I just have to use my laws of positives and negatives and how I group those together to make positive and negative numbers. What is x squared multiplied by 4x squared? How many x's do I see? 4. 4x to the power of 4. Right? I had two x's here, 2 x's there, add them together makes 4. X squared multiplied by negative 6x. Negative 6 times 1 is?
Negative 6.
And then how many x's do I have? 3. X squared in 12 is just 12x squared. 4 times negative 4. And then I have x squared. Negative 4 and negative 6x gives me 24x. Negative 4 and 12 gives me negative 48. Now, the only thing I don't like about this, because technically it could be said, I could have had 9 squares. Do you see? Anybody see how I could have had 9 squares? Like how you're nodding. Why?
The x's.
The x's? Right. Where do I not have any x's? Which column?
Bottom right.
These ones, right? I went x squared in our base x template. I went groups of 1, then groups of
X. X squared.
I have groups of x's, and then I go x squared. I'm missing my x's, so what this could have done, or could have looked like, I have 0x here, and I have my negative 4. All of these would have equaled 0, correct? And then I could have had my negative 16x squared, 24x, and negative 48. Why I like having that process is this helps me organize what I need to combine. Okay, I have 1 of this x to the 4th. Technically this should have been 0x cubed. Then I have these 3. Then I have these 2. Then I have 1. To combine these, how many terms do I have that has 4 or x to the 4th? Well, just the one, 4x 4. How many have x cubed? Guys and girls? Just this one, negative 6 x cubed. How many have x squared? 2. 12x and negative 16x. What's 12 minus 16? Negative 4x squared. How many do I have that is just x? 24. Just 24. And then I have minus 48. Ooh. Are there any questions on this concept? Do you feel better about area model and actually multiplying polynomials? We started at multiplying 4 times 6, and now we're getting to a point where we can multiply 4x squared minus 6x plus 12 by x squared minus 4. Pretty good. Are there any other questions, comments, concerns?